Hi everyone. It's great to be here. Well, here in the virtual sense, talking with you. But sometimes I have to shake my head at the twists and turns life takes. 9 years ago, I knew nothing about computer vision. I'd spent my career working on graphics and optimization. And yet, today, I'm presenting at CVPR. I still feel like I know nothing compared to the people I work with, but I now know a lot more than I used to, and have a deep appreciation for the value of computer vision. I am truly honored to have been asked to speak today. Since I'm not an expert, I'm not going to talk about any technical aspects of computer vision today. Instead, I'm going to talk about how central computer vision is to the AR/VR-based second wave of human-oriented computing, how central that wave is going to be for pretty much everyone on this planet for decades to come, and what a once-in-a-lifetime opportunity this is for all of you. I'm going to start by talking about that second wave of human-oriented computing. And in order to get the proper perspective on that, the place to start is with the first wave, the personal computing revolution that has created the world we all live and work in. That wave came together in the 70s at the Xerox Palo Alto Research Center, where a team of researchers took on the mission to create the office of the future and invented the laser printer, developed Ethernet, refined the mouse, and developed the bitmap windowing interface, wrote the first WYSIWYG word processor, even coined the term object-oriented programming, and then put all that together to build the first personal computer, the Alto. Steve Jobs negotiated 2 visits to see the super-secret Alto in 1979. Here's what he said about that years later. And within 10 minutes, it was obvious to me that all computers would work like this someday. It was obvious. You could argue about how many years it would take. You could argue about who the winners and losers might be. You couldn't argue about the inevitability. It was so obvious. The Macintosh and Windows spread the technology Park had created. Developers built the software we use today on that foundation. Moore's law enabled computers to get much smaller and 1 billion times faster. And the result is a world in which we are all surrounded by and no more than seconds away from the virtual world almost every waking minute. I call this the first wave of human-oriented computing, and it has changed everything. How we work, how we play, how we're entertained, how we communicate, and how we socialize. Still, for all the ways it has changed our lives, we can only interact with that virtual world through 2-dimensional portals. That's obviously very powerful, but it uses only a small subset of the capability to absorb information and perform actions that we have in the real world. AR/VR, in contrast, has the potential to interface with the full range of human capabilities, so that real and virtual can intermix freely. This is the second wave of human-oriented computing, and it is fundamental in a way the first wave is not, because it has the potential to ultimately encompass the entire space of possible human experience. To a very real extent, AR/VR has the potential to deliver literally anything you are physically capable of experiencing. Of course, it will be a very long time before that is entirely the case, but that's part of the appeal of AR/VR. The interesting problems will last for decades. Wearing glasses or a headset also provides a sensor platform that enables egocentric capture of each person's life as they go about their day, to the extent that they choose to have that data captured, and that will make truly personalized, contextualized AI possible. So let's apply Steve's words to the second wave, the one that will be built on AR/VR. You couldn't argue about the inevitability. It was so obvious. Imagine a VR headset that's a sleek, stylish, lightweight visor with a 200-degree field of view, retinal resolution, high dynamic range, and proper depth of focus, with audio that's so real you can't believe it's computer-generated, that lets you mix real and virtual freely, that lets you meet, share, and collaborate with people regardless of distance, and that lets you use your hands to interact with the virtual world. If that existed right now, we'd be working, playing, and connecting in it every day. Imagine AR glasses that are socially acceptable and all-day wearable, that virtualize information devices like your phone, your TV, and virtual workspaces, that give you perceptual superpowers, a context-aware personal assistant, and above all, the ability to connect, share, and collaborate with others anywhere, anytime. If those glasses existed today, we'd all be wearing them right now. To me, that's all as obvious as the future of personal computing was to Steve. There's a huge amount of challenging work yet to do, but everything I've described is doable. We really will be wearing those AR glasses and working, playing, and connecting in VR before too long. There is, however, one minor obstacle. The technology that would allow most of that to happen isn't even close to where it needs to be yet. Great engineering will be needed to create those platforms, for sure, but AR/VR is still very much a research challenge and will be for many years, many decades to come. So, what would it take to build the AR/VR platform that would make it a part of daily life for everyone, that would be so compelling that we'd be doing CVPR in it right now? Rather than starting with technology, I'm going to approach that question from the perspective of what overall user experience we'd want the platform to deliver. And here I'm going to discuss something I've been working toward for a long time, a virtual collaborative workspace. For 5 years now, I've been wishing for a VR workspace that I could configure any way I wanted, with monitor quality virtual screens, holograms, whiteboards, and whatever, saving and switching between configurations with a click. Throw in the ability to interact with my real surroundings and use a keyboard and mouse, and that would be a great work environment. And then, if I could share virtual spaces with other people, it would become an amazingly productive collaborative environment as well. And while I'm at it, it'd be great to have the ability to manipulate both real and virtual objects with my hands, complete with haptic feedback. I would use that in a heartbeat, and I believe that it would spread like wildfire, the way personal computers did back in the day. Even better, the hardware-software stacks and the overall platform needed to enable the full range of uses for that virtual collaborative workspace are so broad and general that they'd enable a vast space of applications and a flood of creativity across gaming, entertainment, communication, education, and productivity. Again, just like personal computers did. I'm highly confident that a great virtual collaborative workspace would open the door to the entire next generation of VR, which in turn would unlock human potential on a massive scale. What would it take to make that collaborative workspace a reality? Without question, we'd need enough resolution and good enough image quality so that virtual monitors were at parity with real monitors. That would require very high-res displays and much improved optics. I personally think that visual acuity needs to be 20/20 or better, but that's just the start. We'd also need the ability to render at that high resolution, and to either do that with a mobile GPU or transmit the data over a wireless link, and that very likely means we would need foveated rendering, which may require a new graphics pipeline and would certainly require great eye tracking. Next, we would need excellent real-time mixed reality so that we could be aware of the world around us and move around and interact with our desk, chair, keyboard, mouse, and other surroundings. We would also want to have persistent, shareable virtual objects in the world so that we could, for example, set up a customized team workroom or work on tech art or some code with a teammate. To do all that, we would need a shareable map of our local physical surroundings, as well as an index of the real and virtual objects within that space. We would also need to be able to see our hands and our body in order to truly be present in the virtual world. And we'd want to do more than just look at our hands. We'd want to use them as the intuitive, highly dexterous manipulators that they are in the real world. So we'd want both haptic gloves and hands so accurate that we can interact with both the real and virtual worlds flawlessly in mixed reality. And if we're going to be doing work with our hands, we'd want clear and comfortable vision within arm's length for hours of use per day. We'd also want proper spatialization and propagation of virtual sound, so virtual objects and spaces would sound as real as they look. For collaborative work, we'd obviously want compelling avatars, so we'd need accurate real-time face, hand, eye, and body motion, as well as highly realistic appearance. Less obviously, we'd need a wider field of view, so that everyone in a meeting could see everyone else. That's essential for social interaction, as are voices that sound like they're coming from the right people in the right places. We'd want to be able to share our real environments with each other, both for social purposes and because physical objects will often be important to the discussion. And finally, we'd want to wrap all this up with great ergonomics to make it comfortable to be in VR for hours at a time. And that would require making everything I've discussed compact and power efficient. And then we'd finally have the complete platform that my dream workspace could be built on. I believe that platform would enable us to work remotely as effectively as in person, or someday, maybe even more effectively, because you could have collaboration tools in the virtual world that could never exist in the real world. The implications of highly productive remote work are far-reaching. For starters, it would make millions of information workers, including all of us, more productive and connected. That alone would be enough to convince me this was worth doing. But there's much more. Imagine if that workspace existed right now. It would be pretty much the most useful thing in the world, short of a vaccine for COVID-19, because it would enable a huge chunk of the economy to work more effectively in an age of lockdowns and social distancing. And even more important, the effect of highly productive remote collaboration would extend far past the current crisis, with the potential to genuinely change the world for the better. People wouldn't need to live near where they work. They could live near family or where housing is affordable, or just wherever appeals to them. Commutes would vanish, and there would be dramatically fewer business trips, with huge energy and environmental benefits. Companies would be able to tap into talent around the world, and the ability of talented people to find meaningful, high-paying work would no longer be determined by where they happen to have been born. I think we can all agree that that would be pretty awesome, but how do we get from here to there? Well, it will clearly take a huge, long-term research and engineering effort on many fronts. Not coincidentally, Facebook Reality Labs has been pushing the envelope for the last 5 years in all these areas that I just talked about. When we step back and look at this list of research areas, it becomes clear why this talk is directly relevant to you. Fully half of that list involves computer vision, and almost no aspect of the virtual collaborative workspace would be possible without CV. For example, people often think the key to AR/VR is the display, but a great display can't do its stuff without VIO to keep the images fixed in the world and eye tracking to enable depth of focus. Let's take a quick look at some of the computer vision research FRL is doing to build the AR/VR future, including, but certainly not limited to, the virtual collaborative workspace. We'll see several videos, and to avoid confusion, I want to be clear that everything in those videos is a full 3D model projected to a 2D image. Let's start with hand tracking, where Robert Wong's hand tracking and input research team, based in our main lab in Redmond, has just shipped hands using only the egocentric monochrome cameras on the Quest VR headset. This is a big step forward for natural, low-friction VR input, and also for self-presence and avatar fidelity. We'll be sharing the details of this work at SIGGRAPH later this summer. Next is eye tracking. This seems much simpler than the other areas listed. After all, how hard could it be to accurately evaluate the pose of a single, near-spherical object from a rigid observation platform? However, glasses and headsets move around on the head. The eye is neither spherical nor rigid, and there is huge variation in both eye and face characteristics across the world's population, so this is a hard problem indeed. As a result, it still remains to be proven that it's possible to track the eye accurately and robustly enough to enable breakthrough features like depth of focus, foveated rendering, and pupil steering. In AR, the challenge is even greater due to the glasses form factor. In Redmond, Rob Cavan and Andy Oderkirk are jointly leading the research teams looking past pupil and glint tracking to new, potentially superior approaches. Next up is physically correct human simulation, led by Ronald Mallet's team at Sausalito. This includes a broad variety of aspects of creating accurate human avatars, including skeletal tracking, cloth simulation, accurate modeling of muscular action, and physically based light transport and skin rendering. Here's a quick sample of their work. Facebook is about connecting people, so one of our key goals is to create truly convincing personalized avatars, avatars that fully convey the nonverbal signals that are normally available only in person, that is, the unique social presence of each person. In addition to the work I've just mentioned, Yasser Sheikh's team in Pittsburgh is developing Codec Avatars, machine-learned avatars that are strikingly close to metrically correct. To see how this is progressing, let's start by looking at one of the first Codec Avatars from more than a year ago.
A good morrow to you, my boy. It's healthier to cook without sugar. Thank you, she said, dusting herself off.
That's amazingly realistic, but the level of expressiveness is pretty low, and expressiveness is perhaps the most critical part of social interaction. One of the important advances over the last year has been capturing more of that, as you can see in this next video from last summer. Here, Kevin's facial animation is being driven in real time entirely by cameras mounted in the headset. Of course, facial expressions only matter if you're interacting with someone. As you watch the next video, you can see Yasser and Danny wearing headsets in the real-world video in the corners. The faces in the center are avatars. And again, they're animated in real time entirely from cameras in the headset.
Well, what can your face do? Can you show us?
Well, I've always hoped you would ask me that question. So I have some pretty good, I think, mouth movement.
How about your eyes? Can you look left, right, up, down? Good.
Yeah, I can do surprise. Ah, ooh. I think one of my favorites is puffing my cheeks.
The mouthwash commercial.
And rolling my tongue.
That's pretty good, actually.
Yeah.
Good.
It's hard to believe that those are real-time reconstructions rather than videos of real people. Although, to be fair, right now it doesn't always work that well. Anyway, it certainly doesn't take a huge leap to imagine how doing that in VR could be far more satisfying and personal than seeing someone's image on a flat screen. Social teleportation will need more than just heads, though, so I'd like to share an initial step toward codec avatar bodies with you.
A codec avatar is a digital representation of a person. And so we build these to look like us, move like us, sound like us, and the purpose of it is to be able to connect people across distances.
Again, this is just a first step. What you saw was generated offline, not in real time, although it will become real time in the not too distant future, and there are still lots of failure cases, but it's promising. All this is still research, with a lot left to do, but codec avatars have certainly come a long way. The day they become consumer ready will be the day it will be a delight to do a presentation like this in VR. Finally, we come to world context, by which I mean all the attributes of the world other than people. This includes tracking, reconstruction, mapping, localization, indexing, object segmentation and identification, and mixed reality, all of which Richard Newcomb's Live Maps research team is working on as part of their Live Maps initiative, with the ultimate goal of building a mapping, localization, and indexing service for the real world and for the virtual objects located within it. Live Maps will enable tracking and sharing of virtual objects, as well as world-locked rendering and contextualized AI inference. Critically, it will allow all of that to happen within the extremely low power and thermal budgets of AR glasses, because it will allow most of the relevant context to be cached, rather than constantly regenerated. I can't possibly do justice to the full range of Live Maps, and I'm sure Richard will share a great deal with you over the next few years, so I'll show just one example of the Live Maps research team's work involving reconstruction. Here's a video showing the process of reconstructing a building as the observer moves around it, speeded up quite a bit. And here's an example of the kind of reconstruction that can be generated from that. That's a real video on the left and a reconstruction of the same scene on the right, complete with mirrors. The only way I can tell the difference is that I can occasionally see the feet and shadow of the person doing the filming in the real video. And here's a sample of the scale on which the Live Maps team is tackling reconstruction. This phenomenal level of reconstruction will enable extraordinarily high-quality mixed reality experiences. And I should note that this is only first-generation technology, which the LiveMaps team is now advancing beyond. This level of reconstruction is especially powerful since once you have a reconstruction, you can do whatever you want with it. Here are some pretty cool lighting effects applied to a reconstruction. Rock-solid mixed reality is a key part of the future of VR, but spaces are far more compelling when shared with other people. It's Codec Avatars together with reconstruction that will start to give us true social teleportation, where anyone can be with anyone else, wherever they want, working with a mix of real and virtual. That's a long way from being mature, but let's take a very early peek at what it would be like. To set the stage, here's a reconstruction of the space in which information for Codec Avatars is captured. Now, let's put a Codec avatar in it.
Restricted only to those people who live close by. That's the promise of it. And this is research work that we've done right here in FRL Pittsburgh. I hope you enjoy the demo that you've seen, and we all look forward to what the future brings. Thank you.
Again, there's a long way to go, but this is a genuine glimpse of the future. And that future is built on computer vision. There are two takeaways I'd like you to come away from this talk with. First, AR/VR is a huge and immensely challenging undertaking, but the second wave is underway, and the results will define our world over the rest of our lifetimes, as surely as the work Xerox PARC did defines how we live today. This is not just another platform shift, it is a paradigm shift that will last for decades or longer, the second wave of human-oriented computing. Second, computer vision is at the heart of this paradigm shift, and because we are still very early in the process, there is tremendous leverage, which means that every one of you has the opportunity to change the world. It is exceedingly rare good fortune to have the chance to do that, and I very much hope you will seize the opportunity and help to make that future happen. Thank you.